What the fuck are vectors? 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 What the
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
Well, he isn't wrong. Okay, so basically, vector describes a vector as a magnitude and a direction. Here's the thing. That's that's a description, not a definition. So we need to start from the beginning. Okay, in Babylon, 400 BC. No. The first use of vectors was actually relatively recent compared to other fields of mathematics. They were first used by 18th century astronomers, according to Wikipedia. So basically, okay, enough with history. In its most fundamental form, a vector is a list of numbers. That's all it is in its most fundamental form. Yeah. So now you might think, but isn't that just a point? Well, you would be correct. In its most simplistic form, it's the exact same, vector and a point. The difference, however, lies in the geometric interpretation of this list of numbers. So, you're probably aware that we live in three spatial dimensions, like forward, upwards, and sideways, whatever the fuck. And you like to know what a system of coordinates is. So imagine holding out your finger and considering it as a point of origin. Where would our point, say, 1, 2, 3 lie? Well, that depends on which axis we use, of course, and what system of coordinates. But I'll get to that later. So, okay, for now, let's just pretend that the first number says how much to the right we move, say like how many centimeters or inches or whatever the fuck. And like the second one is forward and the third one is upward. So then it would be like 1, 2, 3, about somewhere. Yeah. So this is still a point. Of course, this is still a point. Here comes the difference. A vector is described as the line segment between this point and the point of origin. So it's basically this distance. And now vectors, wise words, are starting to make sense because it obviously has a length or a magnitude and it has a direction also. It goes like, yeah, there. So yeah, that's basically what a vector is. It's a line segment, and therefore, as Vector also said, you often associate it with a kind of arrow going from one point to the other. Um, so let's investigate what happens when a line segment doesn't start at the point of origin. So, okay, you still have your point of origin here, and you take two other fingers um, and think about the line segment between them. Does it have a length? Well, yeah, obviously, you can see it. Does it have a direction? Kind of. It has two. Depends on how you view it. So if it goes from here to there, then the direction is there, but the opposite is also true. If it goes from here to there, then the direction is like the opposite direction, of course. Um, and basically, so if I just choose this one where I start here and I end up there, so this is my starting point, we'll call that S, and my end point E. Then the vector associated with the line segment from S to E, we commonly denote that as SE with a little like arrow above pointing to the right. And that then vector SE is then equal to the coordinates of the endpoint minus the coordinates of the starting point. So this might seem a bit counterintuitive at the start, but think about this. Okay, so if we have like our axes here, then you want this vector to be negative in that direction, in this coordinate, this axis. So, and since this is more negative than this is, then the only thing that generates a negative number is this minus this. So it's basically the endpoint minus the starting point is the same as the vector from the starting point to the endpoint. So, well, yeah, now you have a basic knowledge of what a vector is. And to expand on this, you can watch my other videos on bases and axes. And yeah, ha det bra.